Hi everyone, welcome to my channel Tech Tutorials 2K21, and today we are going to learn about a traveling salesman problem, how we are going to solve using brute force technique in design analysis of algorithm. So before solving this problem, we have to know what is a traveling salesman problem first. So let us consider one travel salesman is there. So now he wants to visit different cities and he want to sell his product. So now what the problem will say is, so now we have to find out the shortest tour among all n cities, and he wants to visit each and every city only once, and he return back to his home. So that is a problem given for us. I just read the problem statement for you. So now this is a traveling salesman problem. We have to find a shortest tour through a given n cities that visit each city exactly once, and before returning the city where he started. So for this problem, most probably they will given one undirected weighted graph. So why it is undirected weighted graph? Because I don't have any directions here on my edges, and then we are finding of that different weights are there. Now you can see from A to B he is going to travel, it takes 2 as a cost. So like that each and every edge we have some cost. Okay. So now what brute force technique will say? Brute force is a straightforward technique. So we are not thinking about any logic and thing, and we are going all possible solutions for a given problem. So now for in this example, suppose the salesperson, he wants to start from the city A. So what he said, he want to visit all n cities from a given tour, and he wants to visit each and every city exactly once, and after visiting of all cities again he return back to his place where he started. So in this example we consider the traveling salesman, he started at city A. So now what are the different possibilities we have, like he wants to complete his tour. So let's we find out what are the different possibilities we have. So now we are finding the possibility. Suppose the first possibility we consider, he started at city A and then he wants to visit city B, from there he wants to visit city C, and then D, again he return back to home A. This is one possibility, like he visit all the cities and he return back to the home city where he started. And then like consider the second alternative, like he started from city A and then he is going to visit city B, from there he is going to visit city D, and then there to C and A. So this is another possibility we have. And then the other possibility is, he started at city A, instead of visiting B he started visiting C first, and then from C to D, from D to B, and then B to A. So this is one possibility, and then we will see the other possibilities also. Here we consider the other possibility. So let we consider again the traveling salesman, he started at city A and then he visited next city as C, and from there he wants to visit city B, then city D, then A. So this is one possibility that a traveling salesman is having, and the other two possibilities are, so like he started his journey from A and then he is going to visit D, from there he is going to visit C, B, and then from B he is going to visit C and then A. This is another possibility we have. And then the last possibility is that he started his journey from A and then he is going to visit city D, from there C, from there B, and then he visit A. So these are different possibilities we have with a traveling salesman problem. So now we have to find out the cost of each and every tour. So let's consider the first thing, like from A to B we have a cost as 2, from B to C we have a cost as 8, and then from C to D the cost is 1, from D to A the cost is 7. So what will be the total cost? Now we are adding all these costs, we are finding that the total cost is 18. So this is a first tour solution. Let's consider the second possible solution. From A to B we have a weight as 2 and then B to D, so the weight is 3. So from D to C, the weight is 1, and then from C to A, the weight is 5. So what will be the total cost here? From here the total cost is 11. So now consider about the third tour. So that is from A to C. So we have a cost as 5, and then from C to D the cost is 1, and from D to B the cost is 3, and then B to A the cost is 2. So we are adding this 2, we get the value as 11. And for this, from A to C the possibility is 5, and then C to B the cost is 8, and then B to D the cost is 3, from D to A the cost is 7. So now we can add all these things, we are getting the cost as, see, 11, 18 plus 5, 23. Okay, so now the other possibility is that, so he is going to travel from A to D first, so the cost is 8, okay, A to D the cost is 8, and then from D to B the cost is 3, from B to C the cost is 7, and from C to A the cost is 5. So now we are adding all these things, we are get C 10, 18 plus 5 is 23. So now we have the other and last possibility, that from A to D we have 8, and from D to C we have a weight is 1, and then C to B the weight is 7, and then B to A the weight is 2. So by adding all we are getting like 18. So these are different possibility of tours, let's say traveling salesman is having. So what we have to find out? We have to find out the shortest tour. So that is, among of all the solution we can see the least cost on these two possibilities. So like the traveling salesman either can choose this path or this path. So what is those paths? From A to B he can travel first, and then from B to D he can travel, and from D to C he can travel, and then he return back to his home A. So this is one path. And what is the second alternative we have? From A to D and from C to, like this is C to D, and from D to B, and from B to A. So this is a solution for traveling salesman problem when we solve using brute force technique. Thank you.